All right, we are going to discuss experiment 28, the RC time constant. And so this serves as the intro to that experiment. Of course, I want you to do the advanced study assignment. There are no CI questions, so answer all of them. This is whenever you have a capacitor and a resistor together, the resistor times the capacitor has it forms a time constant. A single time constant is the point you get a rising charge curve that looks like this, and the time constant is the point at which you are at 63% of the total available voltage. So if you had 10 volts, this would be 6.3 volts. We're only working with 3 volts, 3.03 to be exact. So that's we'll read what this says. At time t equals tau equals RC, one time constant, the voltage across the capacitor has grown to a value of 1 minus 1 over E of V0. That is V equals V0, 1 minus E to the minus RC over RC, which is VO times 1 minus E to the minus 1, which VO 1 minus 1 over E, which that equals 0.63 times VO. So you're at 63% of whatever VO is. Now we're gonna look at some data, and we're gonna plot it. And when you plot it, of course, when you plot it, we're often looking at the slope, and the slope is of the form y equals mx plus b. So this is our y. Oops, let me change. This is our y. This here is our mx, and this is our b. So the mx, the slope m is the 1 over RC. So when you plot it, when you plot your data and get a slope, the RC is the inverse of whatever you're getting. Now, on a discharge curve, this is the equation, and again, it takes the form of y equals mx plus b, where this is your y, this 1 over RC is your slope. That's kind of messy, but you understand what I'm doing. And then the natural log of V0 is your B. So let's see. I've done the experiment. I'm going to show you the videos. I don't want you getting the data off the videos. I had a lot of trouble, especially with the first one. So I will have this column and this column populated. I do expect you, and also this column and this column. I do expect you to fill in this column, and this column, and of course all of these, this other ancillary information. The same with data table 2. I'll have this column and this column. Well, I was doing it in red. This column and this column done, along with this column and this column, and you fill out the rest. Let's do it in blue like I did the last one. You fill, oops, I didn't do blue. So let's just erase that. You fill out this column, and this column, and the ancillary information that they ask for here. And then, of course, at the end, you do the questions, and that should take care of it. Go ahead and please read the entire theory and intro. I don't think I forgot anything. My dogs think it's time to eat. That's why they're barking. I apologize for that. But this will serve as the intro. I would like to see the graphs of what you're plotting. You won't get 100% on your lab report if you don't turn in the graphs, okay? All right.